So here is a region of electric field. Electric field is pointing downward. We have 3 points, A, B, and C. We're just going to look at B and C for right now. And B is at location 220 meters. C is at location 200 meters. Electric field is 0, negative 300, 0 newtons per coulomb. So using this relationship between the electric field and the change in potential, what is delta V along a path that goes from B to C? Okay, so 65% says positive something and 30% say negative something. Signs are going to be really, really important here, okay? And we'll say a little bit more about this as we go along. But it's really important to get the signs correct. And so let's work out what the path should be and what the sign should be. The path, really step one in any of these problems is draw the path. Draw the vector from the initial point to the final point. And step two is draw the electric field, but it's given to us in this case. So what's the path? It points from where to where? From B to C. So I draw a path vector, maybe just a path or a dotted line that has an arrow, from B to C, okay? So I can calculate what this path vector is by saying what? What's going to be the path vector? C minus B, right? Final minus initial. So 200 minus 220 meters. And we get 0, negative 2, 0 meters. Okay, it has a negative y component. It's pointing downward. All right. The dot product says, or the change in potential is the negative of the dot product of the electric field and the path vector. So we have a negative out front. We have an electric field that is 0, negative 300, 0 newtons per coulomb, dotted with 0, negative 2, 0 meters. And so I have a negative multiplying 0 times 0 gives me 0, plus negative 300 times negative 2 gives me 600 plus 0. But I have this negative sign up front, so this is a negative 600, and the units are volts. And unfortunately, the abbreviation for volts is V, which looks like the same symbol as the quantity, but we'll just have to deal with it. So it's negative. Negative 600 volts. Answer 6 is correct. Okay, so you've got to be a little bit careful about directions and signs here because they're going to be extremely important. Let's try another one. Same looking situation. We have now the electric field pointing up. B is at 0, 0, 0. C is at 0, negative 2, 0. Electric field is 0, 400, 0 newtons per coulomb. What's delta V, again, from B to C? Okay, a little bit better agreement on the sign this time, but still not perfect. Most of us are saying it is a positive 800 volts. Again, path vector points in the same direction because we're going again from B to C, but the electric field points up. Okay, so we changed the numbers here, but it's still going to work out to be the same path. This B was what? B was 0, 0, 0, and C was 0, negative 2, 0. So the delta L is still going to be C minus B, right? Final minus initial. So we have 0, negative 2, 0, minus 0, 0, 0. Okay, so it just gives us, again, a path vector pointing downward. Electric field is upward, and delta V is a negative of that dot product, 0, 400, 0, dotted with 0, negative 2, 0. And we have negative out front, 0 times 0, 0 plus 400 times negative 2 plus another 0. And the signs cancel and you're left with 800 volts. Positive 800 volts. Okay, so once again, signs got to be a little bit careful. Something that can help you. Remember, from your math classes or from Physics 1, there's another way to think about a dot product. I could say that delta V is the negative of the magnitude of the electric field times the magnitude of delta L times what? What was it? The cosine. Yeah, the cosine of the angle between those two vectors. What's the angle between these two vectors? 90? One's pointing down, one's pointing up, so the angle is 180, around 80. Cosine of 180 is negative 1. Okay, cosine of 180 is negative 1. So if I did that, I would have a negative times the magnitude is, the magnitude of the field is 400. The magnitude of the path is just 2, but the cosine of 180 is negative 1. Again, this gives me a positive 800 volts when I multiply the two negative signs together. Okay? So we can also double check it by looking at the directions. Here's another example. Okay, we have A, B, and C. We're going from A to B. A is at 320. B is at 520 meters. The electric field is pointing down. Negative 0, negative 400, 0 newtons per coulomb. What's delta V along the path from A to B? What we should be doing is drawing the electric field along that path, just to make it clear, so I'll draw it up there. Okay, so most of us are getting this. It's going to give you 0, right? It's going to give you 0. The path, and you can work this out two ways. The path vector is what? Delta L is equal to, what's the x component? 2, y is 0, z is 0. Okay. But the electric field is in the negative y direction, right? So you take this dot product, you have E sub x times, well, let's do it. Delta V is negative E dot dl, or E dot delta L, excuse me. We have 0 times 2 is 0. We have negative 400 times 0 is 0. We have 0 times 0 is 0. Add them all up and you get 0. Okay, so 0 volts. Or we could do it the other way, the way we just talked about by looking at the magnitudes and the angles. We can say that delta V is negative magnitude of L, E times the magnitude of delta L times the cosine of the angle between those two vectors. What's the angle between those two vectors, between the path and the electric field? 90 degrees. Cosine of 90 is 0. Okay, no matter how you slice it, you get 0. All right. That's kind of interesting, that the electric field, if it's perpendicular to the path, gives you a potential difference equal to 0. Let's try another one. We're going from B to C. B is at 0, 0, 0. C is at 0, negative 2, 0. And now the electric field has several components, an X and a Y component. What's change in potential, delta V, from B to C? All right, so we're getting this, right? The answer is going to be negative 600. The field has more than one component, but what did you notice? Did the X component of the field even matter in this case? No, because that gives that when you calculate the dot product, the X terms are going to give you 0 because you have a path that's only in the Y direction. So our electric field, point something like that. And what did we say B was? B was at 0, 0, 0, C at negative 0, negative 2. Okay. So electric field dot negative electric field dot delta L is delta V. We have then negative of EX, which was negative 200, times the path delta X component, which is 0, right? So delta L is again 0, negative 2, 0 meters, times 0 plus negative 600, or excuse me, negative 300 times negative 2 plus 0 times 0. All negated. So that's 0, that's 0. This is going to give us a positive 600, and then we multiply it by a negative sign. We get negative 600 volts. Okay?